Dear environmental agents, I'm Xiaoyue Shi from Earth Science Department in UCL. I'm here to presenting my environmental quality assessment and proposing the construction of new tube line called Streamline. I will introduce from two perspectives: environmental analysis with respect to air quality measurements and geological reference to lithologies under the London Basin. London has the oldest underground history, origins in the Metropolitan Railway, opened in 1863. The first underground line started operating in 1890 and is now part of the Northern Line. Tunnels and tubes are continuously developing in London. With respect to age, depth, tunnel distance, and ventilation of tube lines, and passenger population, air quality in London Underground system is worse than other subways worldwide. This is the methodology of my field data collection. I have sacrificed temporal variability for better precision by sticking the time on Fridays from 2 p.m. The anomalies I have observed are not processed in QGIS analysis, so more advanced skills in QGIS might be helpful to solve this challenge. I have taken averages of all data for neatness and decided to focus on platform readings, as I think it is more representative and collections of platform readings are more organized in all tube lines. From this page, I will first show my analysis based on field data collected by myself and my colleagues, following with the heat maps reproduced by authorities. Beginning with the air quality index, the highest AQI is observed in this area. The horizontal line is Central Line. This is the combination of Victoria and Piccadilly Line, and the highest AQI follows along the Northern Line. There's also some spots of medium value of AQI observed, and this is observed in DLR. Following with PM 2.5, certain lines are more distinctive from the rest. The Northern Line is still the worst in terms of air quality. Central Line shines a little bit. The spots here are where Piccadilly and Victoria lines coincide. PM10 follows a similar pattern, with the highlights on Northern Line. The stations has the highest values are Clapham South and Clapham Common, Belsize Park, and Chalk Farm. It can be summarized that the overall air quality is the worst in this area based on the three parameters, with particular highlights on the Charing Cross branch of Northern Line. The following 4 pages are figures reproduced by authority. They have implemented measuring across the whole area of London, generating continuous data. It is consistent with my field analysis that higher readings of PM 2.5 in central London, but it shows more circular expansion outward from the center. My results of PM10 seems less consistent with the publication, where PM10 reviews medium value in central London and the lower value in outer London, but all 4 parameters are primary pollutants that directly connected to vehicles' emission, so higher values of all 4 parameters are found in main roads. Though nitrogen dioxide and nitrogen oxides are not investigated in my field measurements, it is worth discussing. Circular outward expansion from the city center is discovered for both nitrogen dioxide and nitrogen oxides. The area at the West London, at boroughs of Hillingdon, Ealing, and Hounslow shows even higher readings than central London, but this is not the focus of this project. The results of nitrogen oxides show high similarity with the results of nitrogen dioxide. To summarize the environmental aspects of discussion, the measurements and analysis concentrated on precision and focused on winter season at platforms, generating discrete statistics of air quality parameters. Meanwhile, the methodology differentiates among groups and left gaps of other non-numerical field observation. More advanced analytical themes could be included to assist more in-depth understanding. The geologic aspect of London is started by discussing of 6 rock units drilled for boreholes: drift gravel, London clay, Lambeth group, tannin sand, and chalk. Begin with gravel. The course of Thames has been altered by the most extensive glaciation, called Anglian glaciation. The present Thames drainage platform has been dominated by the cyclic development of a sequence of terrace gravel aggregation under pre-glacial conditions. London clay is the lithologically monoderous marine clay under central London, and has been a major factor in early development of deep underground transportation network. Its properties imply the excellent load-bearing capacity. There are 6 chalk formations presented in London Basin, which are distinguished by the presence or absence of moor and flint bands. Physical properties including density, porosity, and color. The seaboard chalk formation has been identified in Abbey Wood. To better understand the lithologies in the London Basin, I have also visited these 3 sites with geology exclusion. Hampstead Heath lied on London clay, and Abbey Wood preserves clay outcrops of seaboard chalk formation, and Upper Thames sand, which is not observed. Crystal Palace Park reconstructs geological illustrations in longer timescales. More detailed interpretations are taken on Notebook and Google Earth Tour. The following slides are 3D and 2D cross-section models of subsurface rock units. The borehole data are derived from pore and a series of sources in 2016. A shallow anticline in chalk is observed in north-central London, resulting to a pronounced thinning of succeeding strata. And in the London area, the total thickness of chalk preserved is only between 170 to 210 meters, and it is gradually thinning from west to east. An exaggeration of 25 times has been applied for all 3D models for better presentation. London clay is the thickest in the west of the city, and along a thin finger that extends eastwards over the axis of London Basin, and the drift gravel and lambeth group are relatively thinner. Cross-sections of underlying rock units and specific tubeline is constructed. The geologic cross-section of Bank Branch of Northern Line is distorted with exaggerated y-axis of elevation. This is caused by the deepest chalk formation in London, as shown in the 3D layer. In previous slides, the poor air quality conditions at certain areas and the well-developed borehole system under London has strongly suggested the necessity of continuous investment on tube systems. Considering mode shares of passengers, a more connected transport network is also preferred. In conclusion, the Streamline is proposed for construction, starting from the Islington, going through St. Paul's Cathedral, across the Thames River to Tate Modern, then going parallel with Northern Line through Lambeth Borough towards Wandsworth Borough, with an elevation range of around 20 meters to -20 meters. The north section cuts among London Clay and Lambeth Group, where London Clay layer is thinner. Continuing south, Streamline will be located in between drift gravel and London Clay. Interpretations of geology of borehole data might be subjective, and the tunneling below London Clay is more complicated and requires more expensive techniques to stabilize the unpredictable lower London territory deposition, such as ground freezing, dewatering, and chemical grouting. During the further discovery and investigation of implementing the new Streamline, some remedial strategies could also be helpful to bring transient air quality improvement. Thank you.